Hi, hello. My name is Muhammad Ali from Mechanical Engineering. Title of the topic: Shockwave interaction with supersonic aircraft wings. Subject: Fluid mechanics. Shockwave interaction with supersonic aircraft wings on overview. Supersonic flight exceeds Mach 1. The speed of sound shockwaves cause sudden pressure and density changes in airflow. Wing design is critical to managing these shockwave interactions for safe and efficient flight. Fundamentals of shockwave formation: first, compression waves; second, Prandtl chloride singularity; third, shockwave types; fourth, shock strength. Compression waves coalesce into shockwaves at speeds above Mach 1 speed. Predator chloride singularity initial shock as shock formation starts near the leading edge. Shockwave types: oblique and normal shocks differ in angle and pressure effects. Shock strength increases with Mach number intensity. Aerodynamic effects on supersonic wings: first, increased drag; second, lift reduction; third, boundary layer separation; fourth, shock induced BL separation. Increased drag. Shock waves cause energy loss, raising drag significantly. Lift reduction. Pressure changes after lift distribution, affecting stability. Third, boundary layer separation. Turbulence caused by shocks can lead to stall risks. Shock induced BL separation. Complex physics, challenging design, and control. Shockwave boundary layer interaction (SBLI) mechanism: adverse pressure gradient, heat transfer, noise generation. First mechanism: adverse pressure gradient mechanism. Shockwave hits boundary layer causing flow disturbance. Adverse pressure gradient leads to flow reversal and boundary layer separation. Heat transfer: increased thermal loads on wing surface create stress. This stress can affect to destroy. Noise generation: turbulence and shock oscillations can cause intense noise. Wing design for supersonic flight: thin airfoil, swept wings, supercritical airfoils. Area ruling: first, thin airfoil minimizes wave drag and shock strength. Swept wings delays shockwave formation for smoother airflow. Supercritical airfoils is a trailer pressure to reduce drag peaks. Area ruling minimizes abrupt cross-sectional changes for efficiency. active flow control techniques, boundary layer suction, vertex generators, microjets, pulse jets. Boundary layer suction removes low energy air to delay separation. Vertex generators energize flow, keeping it attached to the wing. Microjets inject high momentum air for improved flow control. Pulse jets unsteady air forcing enhances mixing and stability. Numerical simulation and modeling. First, CFD, next RANS, RANS, LES, LIS, DNS. First, CFD stimulates complex supersonic flow patterns accurately, common approach, balancing accuracy and cost in RANs. Lens captures detailed turbulence with high fidelity. In DNS, most detailed but computationally expensive method in numerical simulation and modeling process. Experimental validation techniques, wind tunnel testing, scleral imaging, third pressure sensitive paint, fourth high speed PIV. In experimental validation techniques, first wind tunnel testing, scaled models reveal flow and shock behavior, scleral imaging, visualize air density gradients around wing surfaces, pressure sensitive paint measures surface pressure distribution accurately, high speed PAV maps velocity fields in high detail flow analysis. In future trends in supersonic wing design. Future trends in supersonic wing design. First, laminar flow control reduces skin friction drag for efficiency. Second, adaptive wings change shape dynamically for optimal performance. Shockwave cancellation. Third, interferes shock waves to lessen wave drag. Hypersonic vehicles addresses new challenges behind Mach 5 speeds. In conclusion, critical management, multidisciplinary approach, future advancements. In conclusion, critical management, handling shockwave interaction is key for efficient flight. Multidisciplinary approach combines aerodynamics, materials, and controls engineering. Future advancement enabling faster, quieter, and more efficient aircraft. And last, Thank you all.